Hello dear students and welcome to question 7a. The question is simple. It reads express f as a Cartesian vector, then determine its coordinate, direction, angles. Oops. So definitely this question is okay, not as easy as it looks, but look at this. We have got point A and point B. Okay, definitely we'll need a unit vector in the direction AB, and then use that unit vector to do what? To multiply by f. There we'll get our f in Cartesian vector form, isn't it? Correct. So after we get our f in Cartesian vector form, the next thing we are going to do is simply to get the direction angles, we'll shift the origin and bring it to A. We'll bring the origin to A. And when we bring the origin to A, we'll be able to nicely determine the direction angles, okay, by simply just finding the magnitude for in this case we can use either the position vector itself or we can use the force itself, no problem. We'll find the magnitude of the force and then find the direction angles. Anyhow, let's go. So okay, so let's just do this. Let's do it. So need again we'll start with getting the coordinates for A and the coordinates for B. To get the coordinates for A, or the position vector RA, let's say RA is equal to, we've been given these angles. We've been given the 70, which is from the XY plane to the position vector RA, there we can see, and then we've been given the 30 degrees there. So definitely not so tricky, so to say. So RA is equal to, from what I see here, the x will be 10. The x will be 10 cos 70 degrees, okay, and that would make me find that prime. Then after I find the prime, then it will be sine 30 degrees, okay. So that is the RA, the I. This is the I, okay, and then the J will be, by the way, this, because the X is in this direction, obviously this is negative. Yes, that's negative. Okay, then the Y is positive. It's as you can see, it's plus 10 cos 70 degrees, and then we say what? Cos 30 degrees. That's our what? That's our wow. we have overzoomed this thing, isn't it? Okay, we'll work like this, I guess. We have definitely overzoomed it. That's our J. And then for our K, it's simply plus 10 sine 70 degrees. Okay, there we go. Okay, then for RB, bear with me here, we have definitely overzoomed this thing. So our RB will be equal to, from what I'm seeing here, the X is 5i, and then minus 7j, and there is no k, 0k. So 5i minus 7j. So R AB is equal to RB minus RA, which is equal to this will be RB, then it will be 5 minus, now let me compute this. I'm saying cos 70 times, okay, times sine 30. Okay, fine. So this will be minus that, so this will be plus 1.7 1.710. Okay, awesome, just like that. So this will be the I, and then for the J to be plus RB is equal to minus 7, then minus, this will be cos 30. Okay, so this one comes to minus 0, minus not 0, sorry, so this comes to 2.962 J, and then it should be a minus at the end, since we are moving from A to 0, so that will be sine 70, which is just 9.397. Okay, so this is our position vector. It's when we write it in compact form, we are saying 6.710i minus 9.92, 9.62 J, and then minus 9.397 K. Okay, magnitude of RAB is equal to the square root of this, which is 6.710 squared plus minus 9.962 squared plus minus 9.397 squared. Calculate this, it's coming to 15.25. Yeah. And then with this in mind, we can get our unit vector. Unit vector in the direction of AB is equal to, you do the division there, right, so you just divide the magnitude there, so you have 0.44 I minus 0.653J minus 0.616K. That's what I'm having. Then I express my F in Cartesian vector form. It will be equal to F times UAB, which is equal to 135 multiplied by 0.44I minus 0.653J minus 0.616K. Alright, so our F as a vector, then it's equal to 59.40I minus 88.18J minus 83.18K. Okay, so this put pounds there, so this is our answer. Okay, the direction angles, it's not a big deal to determine them. Actually, it's not a big deal, not at all, because we already got actually okay, direction cosines, isn't it? I don't even know how we are doing it, because I already have a unit vector in that direction. Its magnitude is 1, so I'm saying alpha is then equal to the cos inverse of 0.44, because that's the unit vector. So this should be cos, this should be cos alpha, this should be cos beta, and the other one should be cos gamma. This should be cos alpha, cos beta, and cos gamma, those. Okay, so that should be a bit problem. So beta again is equal to cos inverse of minus 0.653. Awesome. So this will answer here 63.9 degrees, and here 131 degrees, and for gamma is equal to cos inverse of negative 0.616, which is equal to 128 degrees. So we found the direction angles. Okay, so this one at least was not too much, but I hope you have you've seen how we have solved. So this is answer, 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 answer. Pardon, we overzoomed it, so it became a little bit faint, but I hope we are able to see. Thank you.